Okay, so moving on from our previous lecture of object-oriented programming. So if you are, if you needed some recap of what we've done before, so you can go visit the video links as as previously shared. Okay, now let's discuss what is the concept of garbage collection with respect to your object-oriented programming. Okay, the thing is basically that when we're talking about objects, object is basically an actual example of a class that is existing. So it's a physical example. It's the real existence of a class. As far as a class goes, it's basically a description. It's a layout. It doesn't exist actually right now. But when I'm talking about something that is existing, that means there's a physical example of it. Now, when we're talking about computing and programming and code and running code, our physical existence of a running code is in the main memory. So naturally, if an object exists, and there's a physical example of an object, naturally it will be something in my main memory. So in this case, if an object has been created, it will exist in my main memory. Now, that's how objects are. This presents a problem. Now, the problem is that obviously my memory is a limited storage device. And if I continue creating objects without taking care of them, eventually I will run out of my memory. Now, different programming languages have different methods for dealing with your objects, and we will look at how that's happening right now. So basically, if you look at Python, because since we're studying Python, uh, your Python basically applies, it takes care of objects that have not been used. So all Python objects and data structures that have been created, they end up in a private heap. And the Python heap is basically the garbage collection in Python is handled by the interpreter itself. And essentially, if all objects that are no longer needed or no longer used, they're automatically taken care of by Python itself. So I, as a programmer, don't have to include anything in my code to make sure that those objects are now missing or the memory locations are now freed up. Same thing goes with VB.NET. And in VB.NET, a garbage collector is running in the background. And basically it takes care of its objects that has been created automatically. And Java and your C#.NET will also be doing the same thing. So basically, the programmers are, not bothered by removing objects that have been created no longer used. So thereby, your memory is basically managed automatically without the programmer have to worry about it. Our languages such as Pascal, you have to remove the objects that are no longer required yourself. And the way you do that is basically you have, for example, this object right here, this book. And if you no longer need this object, you'll have to call this book dot free. And that way, this object will be removed from the main memory. So apart from Pascal, most modern languages, Python, VB.NET, C#.NET, and Java also take care of garbage collection on its own. Now, since we're taking care of that, we're going to be now moving on with something known as polymorphism. Okay, we've sort of studied for polymorphism, it is important that you know how inheritance works. So we've covered inheritance in the previous lectures. And basically inheritance means that I have two or more classes that share common features. And instead of repeating those features in all classes, what you can do is that you can collect all those common features and create a superclass. And thereby, you don't have to repeat those attributes as well as their methods in all other classes, all the classes where those features are, common. This reduces your size of code. This reduces your effort of programming and allows for, adding more features that may have some common attributes to this class that you just created. Now, if you are collecting all common attributes together in a class, and this class will be known as your abstract class. This is your parent class or superclass. And it is an abstract class. Why? because this superclass cannot be objectified. This cannot be, no object can be created for this superclass. And all classes that share common features of this superclass will basically inherit those common features from this superclass. And that is basically the principle of inheritance. We were looking at this example of library item, and we have two library items of books and CDs. They have many features that are common. And what basically we generically call both of these, a class called library item. And basically our library item can either be a book or a CD. So all common attributes, common features that are both, in book and CD are shared in this library item class. And everything is basically inherited from this library item class. So basically inheritance has to take place. Now, an added feature that you can implement in inheritance is polymorphism. Now, essentially, polymorphism means that I have a subroutine, a method in a child class or a subclass, and it's the exact same name as a method that has been used in your library item class or your superclass. It's the exact same name. So essentially, I am redefining a subroutine or a method that I've used in my parent class again in my subclass. I'm redefining it. Now, why would I want to redefine it? Because inheritance is basically allows me to use those features without creating definitions of my own. But polymorphism is basically creating another method in one of the child classes or subclasses, and and the method has to be the exact same name as the parent class. But the thing is, if that method is called from a child class, it will behave differently. Now, as you can see here, there is a method in my superclass known as print details. So naturally, this print details will be available to me for my book class as well as my CD class. So if an object of either one of these classes is created, they can very easily use these methods when they want, because it's an inherited common feature. However, if I want, I could create a print details separate for my book class, specifically just for my book class. And that print details will also hold the same name as the superclass print details, and it will behave, however, differently. Now, imagine that this method definition over here, print details, is being carried out in my class definition of my subclass, my class definition of my subclass. So I'm defining a method in my subclass, my book subclass, by the name of print details. As you can see that this is the exact same name as the print details in my parent class. And that's okay. The thing is, this is behaving differently. Now, how is this behaving differently? This print details specifically for a book class object, if I call a print details subroutine for a book class object, this print details will run. However, if I call a print details subroutine for my CD class object, the original print details will run. So this is only limited to book subclass. Now, how is this behaving differently? My normal print details look something like this. As you can see here in my previous definition, my print details, this is my print details right here. Original parent class print details looks like this. I'm simply printing all of the attributes of my library item separated by these semicolons written in a single line, right? All of these details, right? Now, this is what is available to what was originally available to both the book subclass as well as the CD subclass. Okay. Now, I'm going to change this for my book subclass only. The CD subclass will use it as it is, but the book subclass will use it differently. Now, this definition exists for the book subclass only. So, and as mentioned, this definition will be part of my book subclass definition, method definition. Now, see what's happening here. I'm defining a subroutine by the name of print details. It has to be the same way. And how is it behaving differently? That I am printing this string as well as this string in addition to what everything my library item was doing right here. All of these details are printed. So original library print details is basically printing all of the details. So originally that's what it was doing. Now, if I wanted to add some additional features limited only to my book subclass, I can do that. As you can see here, a print details method for my book subclass is doing all of the things that was previously done for my library parent class. All of these things are happening here. And how do I know this? Because this is the print details that is linking to library item dot print details. So this print details is called, it means that the original definition of print details is being run here first. Apart from this, additional features for the book print details are that apart from the parent print details, this string is also being printed, and also this attribute is being printed. So that means is that if I call print details for a CD class object, the original print details that was defined in the library item that simply prints out all attributes divided by semicolon, so on and so forth, will be done here. No additional feature whatsoever. However, if a book object, book class object was calling print details, it will behave differently. How? Well, apart from the basic task it's supposed to do, it will also do these two additional tasks. And this is basically what polymorphism is. A subroutine, when called for a child object of one type, will behave differently for the same routine called for a child object of another type. Even though the subroutine is the same name, but it's behaving differently. Now, why would I want to do this? Well, it is possible that you may want a particular child object to have slightly different, just a little bit of different changes. So as you can see here, other than all details printing, the only difference here is that these two lines are added. The rest is the same. So if I just want minor changes to a particular child, I can do that. And this is what polymorphism is. Okay, so let's continue with our previous example where I was basically, we created a vehicle parent class, and we got two subclasses, truck and car. And now we're gonna add a subroutine here. We're gonna call it def print details, sort of like what we just covered in the book. And no parameters required here. And we're simply gonna do what? Print self dot vehicle ID and separate it with a space, then follow it up with a vehicle ID separated by this. Okay. After that, we have self double underscore engine type. And then we got another space. And then we got the owner, self, comma, self double underscore owner, like this. So this basically is printing all of the attributes that are common that are mentioned over here. So since this is defined in my parent subclass, so that means all the child subclasses will have access to this. Okay. Now, as far as polymorphism goes, right? So what we're going to do is we're going to apply polymorphism here. Okay, polymorphism. What we're going to do is that in the car subclass, we're going to make this print detail behave differently. And how differently? So if the object as engine type has the value, say, hybrid in it, then for hybrid, we will add additional prompts, say, stating that it is eligible for some green discount or something like that, right? Or something. Yeah, now that's something that's not available for the truck, but if it's a car, then we can do that, right? So again, we will have to define another procedure here, and it has to be the same name as the one over here. So print details comes again, and we got self, no parameter needed. Okay, first, what I will do is I will make this behave a little differently, right? So how is this different? First of all, I want to call the print details of the parent uh, class always, parent class. So what we're going to do is vehicle dot print details will be called first. That happens. After that, I'm going to do something different now. Okay. So what I'm going to do is I'm going to create a variable here, type of type. No, I can't use this. Okay, type of string, and we can call this engine type. In fact, e underscore type, and we will do type string, and what we'll do is e underscore type is equal to self dot get engine. Get engine, we have get engine. Yes, we can get in self dot get engine. So it will simply return the engine type from in this variable over here. Okay. After that, once I do that, I'll score get, okay, we'll call that. Now, if e underscore type is equal to hybrid or hybrid, then we're going to print something special different for it. Print you are eligible for green discount on tax or tax free, whatever. And else e type is hybrid or electric, or e underscore type is equal to electric. Say the car is eligible for green discount on tax. Otherwise, print no green discount on tax, like so. And that's how print details for a car subclass will behave differently. Now, this is code that we created in the previous class. I'm going to use it again. And here, what I'm simply going to do is I'm going to call the subroutine. As you can see here, choice one for was truck. So if it's a truck object, I'm simply going to call my print details sub method for a truck object. So my truck was the name of the object that we used in the last class, dot print details. And you will see that this will print details as it was intended in the original parent class. However, if I use this same routine here in this subroutine for car classes, here, if I use this, my car dot print details, it will behave differently. So let's check this code out. Okay, so if you remember here from the previous lecture, basically when the code runs, it gives you an option of selecting one for truck, two for car. So let's try creating a truck object first. So this is the truck object. It's asking for a truck ID 001. Okay, engine type diesel, max load 5,000, owner's name Jack. So it's working. So as you can see here, in this last line over here, this is essentially running print details that is defined in my vehicle class. And what is that doing is that is printing the vehicle ID followed by a space, followed by engine type, followed by another space, and followed by the owner. So this is print details running for a truck object. Now let's call this program again. This time we're going to be choosing a car object. So choose 2 for car. We got car here. So enter the car ID. We're going to call it 003 engine. Now, since our code is supposed to behave differently for hybrid, electric, or something else. So let's check how hybrid. We have an engine that is hybrid. Max number of passengers, say 5. Owner's name, John. Now, as you can see here, the print details subroutine is being called here in the final thing. So I got the original print details running, in which the ID, the engine type for ID space, engine space, owner's name is being printed as it was for the truck. So that's as far as this line is goes, it is running it as intended originally in the parent class. So there's no change about that. Now the print details when called for a car object is behaving differently in this sense that it first runs the original print details from the vehicle, because of which this string is being printed as it is. And the additional feature is that it's printing this prompt based on what value is being entered here. So since the engine type is hybrid, then it's mentioning that you are eligible for the green discount on test. Let's try it again. So something for some, so let's say petrol. 2004 engine is petrol. Petrol. Number of passengers 5. Owner's name Daniel. Okay, not green discount on tax. So since we entered petrol and our green discount is only available on hybrid and electric, so in either case it's working fine. But the thing is, this print details when called for a car class is behaving differently. So that's what's happening here. I'm simply running print details here for a car subclass right about here. As you can see here, print details for a car subclass. And what it's doing is that it's running the original print details first, because of which this string is print. And then afterwards, I'm simply comparing the engine type. And if the engine type is this or this, I'm printing this. Otherwise, I'm printing no, not green discount. So that's polymorphism.